Hi students, welcome back into my channel again. Today we are going to learn how we find the solutions of a past paper, especially paper 3, theory, uh, subject physics, and then this past paper of October, November 2022, number 31. Okay, let's start. Number 1. Figure 1.1 shows a measuring cylinder containing some water. State the volume of the water in the measuring cylinder. This one, of course, 21. Okay, 21 centimeters cube. Next, a student adds 20 drops of water to the water that is in the measuring cylinder in figure 1.1. The new volume of water in the measuring cylinder is 25 centimeters cubed. Calculate the average volume of one drop of water. Okay, it means 25. Okay, 25 minus 21. This number. Okay, 21. And it means the average, it could be 25 minus 21 equal 4. 4 over 20 because 20 drops. So 20 is going to be 0.2. Okay, so 0.2 here. A student has a measuring cylinder and a small, irregularly shaped piece of metal. The piece of metal can easily fit into the measuring cylinder. Describe how the student can use the measuring cylinder and some water to find the volume of metal. Okay. It means the first one, I'm going to use whether it's one eye. Okay. One eye. Measuring, we should measuring volume of water first. Okay. And afterwards, we should add the metal inside the measuring cylinder. Okay, and then after that, uh, the metal, yeah, be some will be the metal will be submerged. Okay, and then after the metal submerged, we should measuring volume volume of water again after after the metal put inside the measuring cylinder. Okay, for the volume of water. Wait. Okay, and fifth, the fifth step, we should compare the difference. Okay, the difference. Yeah, the difference no, between two volumes. Okay. Yeah, we should compare the first volume and the second volumes. Okay, then we're gonna measuring uh, we're gonna measuring the volume. Okay, Next, figure 2.1 shows the horizontal forces acting on a car. Okay, calculate the resultant horizontal force on the car. Of course, 1,200 minus 900. Okay, so this one 900 actually, not 8. Okay, 900. Okay, and so equals how much? Equals 300. Okay, so the size of force equals 300. Okay, and then direction, of course, to the right or forward to forward. Okay, or to the right. If you want to answer to the right, no problem. Next, B, a student uses a digital stopwatch to measure the time for the car to travel 100 meters. Figure 2.2 shows the time reading on the stopwatch. Okay. Using the information in figure 2.2, state the time taken to travel 100 meters. Okay, time travel for 100 meters, of course. This one 7. Okay, 7 seconds and 0.2 seconds. So 7 seconds plus 0.2. Why 0.2? Because 20 over 100. 20 over 100 equals 7. Sorry, equals 0.2. So the result equals 7.2. Okay. Next, the car takes 12.8 seconds to travel the next 200 meters. Calculate the average speed of the car for this 200 meters. Okay, average car, it means the average speed, average speed, it means 200 meters. Okay, 200 meters over 12.8 seconds. So if you calculate, it's going to be 15.625. Yeah, 15. So the answer is 115. Or if you round off becomes, you may writing becomes 16, but I will writing 15.625. Okay. Next. See, figure 2.3 shows the speed time graph for another car. Okay. And now calculate the distance traveled by this car between time 2 seconds and time 6 seconds. Okay. So if you look this 2 seconds, okay, that's 6 seconds. Okay. I'm gonna calculate this trapezium area. Okay, area of this trapezium or distance. We're gonna calculate the area of trapezium for half times 6, because this is if you this one, yeah, sorry, it's 6. Okay, and this is 18. Okay, so it will be 6 plus 18 and times this is 4. Okay, 4. Why 4? Because 6 minus 2. 6 minus 2 equal 4. So it could be multiplied by 4. So If you calculate, becomes 2 times 20, 24. It's gonna be 48. Okay. So the answer is 48 here. Okay. Next, a sailor uses a winch to raise a soil on boat. Figure 3.1 shows the sailor turning the winch. Okay. Look, this the winch. Okay, this is the sail. Then the questions. The sailor applies a force of 200 newtons at a distance of 30 centimeters from the pivot in the winds, as shown in figure 3.2. Okay. Okay, the question. Calculate the moment of this force about the pivot. Okay, it means we're gonna calculate there is okay, moment of force. Okay, and moment of force. The moment of force equal force, okay, times distance. Okay, look this figure again. This force 200 newtons times distance. Distance 130 centimeters. Okay, so equal 200 newtons times 30 centimeters equals 2000 Newton centimeters. So answer here 2000, sorry, not 2000, 6,000. So not 2000, but 6,000 because 200 times 30. Next. B, describe two useful energy transfer when the sailor uses the winds to raise the sail. Okay, so the first one, chemical energy. Okay, chemical energy from the sailor becomes potential energy. Okay. Secondly, uh, chemical energy as well. Okay, from the sailor becomes kinetic energy. Okay. Now, this question, describe one non-useful energy transfer when the sailor uses the winds to raise the sail. Oh, several, but I want to answer as sound energy because when the sailor operating uh, the winds, it will be have sound there. Okay, and the sound energy actually unuseful uh, for for the sailor. Yeah, so the sailor. mm, the sailor doesn't need. Okay, next. A student has an object with a mass 5 kilograms. Calculate the weight of the object. So, okay, weight W, the formula equals um, M times G. Okay, M times G. So equals mass is 5 times 10. Okay, 5 kilograms times 10 Newton per kilogram. So the solution is 50 Newton. Okay, 50 Newtons. Next, the students lift the 5 kilograms object from the floor onto a table. He does 75 joule of work on the object in lifting it onto the table. State the amount of gravitational potential energy gained by the object due to being lifted onto the table. So gravitational potential energy, uh, the students gain by this object, of course, this one, 75 joules. Okay. Hmm. It's only potential energy formula like this. Potential energy formula M times G times H. Okay. Well, we will not apply that. Next, the weight of a table is 280 newtons. The table has 4 legs. Okay. The area of each table leg in contact with the floor is 18 centimeters square. Or uh, each table leg. Each table leg area is 18. Okay. Calculate the pressure of the table on the floor. Give the correct unit. Okay. So, okay. The pressure, okay. Uh, pressure equals, okay, 200, 280, I mean, 280 newtons, okay, over 18 centimeters square. So it's going to be divided with, okay, 3.89 Newton over centimeters square. Or we may round off becomes 4. Okay, 4 Newton centimeters square. Okay, 4 here, and the unit Newton centimeters power -2. Okay, done. Next, number 5. Number 5, an engineer measures the pressure of the gas in a gas bottle. Figure 5.1 shows the measuring device has uses connected to the gas bottle. Ah, okay. This is the manometer, I think. Next, atmospheric pressure is 756 millimeters of mercury. Calculate the pressure of the gas in the gas bottle. Oh, we need to calculate the pressure of this manometer. Okay, so 756 millimeters, and then we need to find the height. This one, how much this? 180, 180. Okay, and this one apparently 60. So 180 minus 60 equal 120. So it means um, the pressure equals 756 plus 120. Okay. And it's going to be how much this? 876 millimeters. Or we may round off become, yeah, better, no need to round off, I think so. The answer is uh, this one. Yeah. 876. State the name of the measuring device shown in figure 5.1. Manometer. Okay. Okay, manometer. That one. Okay. Next. All this. B. Some gas is trapped in a cylinder seat with a movable piston. Figure 5.2 shows the arrangement. Okay, describe how the gas exert a pressure on the cylinder. Use your ideas about molecules. Okay, molecules actually, molecules in gas moving high speed. Yeah, yeah, molecule in gas moving high speed, it goes inside the cylinder. Okay, okay, and then it will and it collates, I think it collates the cylinder wall. So that's what. Okay, next. The piston moves and increases the volume occupied by the gas. The temperature of the gas remains constant, and in figure 5.3 shows the new positions of the piston. Okay, state and explain what happens to the pressure of the gas inside the cylinder. Okay, so what happens? The pressure will be decreased. Yeah, yeah, will be decreased because sorry, because yeah, because gas has more more space and yeah implicated to reduce the pressure. Okay, uh, to reduce the pressure and also yeah, to reduce the collision to reduce the pressure. Okay, next. Number six, students investigates wave properties. He uses waves on the surface of a tank of water to show the properties. Okay. Next, state the name of the effect sound. Okay, the name of the effect sound is refraction. Okay, so different between refractions and reflection, but this one is refraction. Sure. Okay. When a wave passes from deep water to shallow water, two of its properties change. Describe how one of these properties changes. Okay, of course, speed. Okay, the wave speed. Okay, speed of waves. Okay, next, a change in property, wave fronts. Okay, in shallow, yeah, in shallow area is slower. It will be slower because the deep is different with the previous locations of water of the waves. I mean, next, the students knows that it takes 10 seconds to produce 25 complete waves in the water tank. Calculate the frequency of the waves. Oh, okay, we're gonna calculate the frequency of the waves. Okay, the frequency, the frequency formula equal, okay, this one 25 waves, yeah, over 10 seconds. 25 waves as long as 10 seconds. So it's going to be 25 over 10, and it's going to be 2.5. That's the answer, 2.5. Okay, next. Waves on the surface of water are transfer waves. State one other example of transfer wave. Okay, a transfer wave. Okay, so C1, uh, the electromagnetic wave. Okay, electromagnetic wave. Okay, electromagnetic wave is a kind of transverse wave. Okay, this one double I. Wait. Describe the vibrations of particles in a transverse wave. Okay, vibrations mean the vibration of particles direction perpendicular. Wait, perpendicular. Perpendicular. Yeah. So the vibration particle, the direction perpendicular for to to the shoreline, to the shallow shoreline. Sorry. Okay, that's one. The answer. Okay, next. Number 7. A student has a bar magnet and a metal bar with ends X and Y. The student moves its pole of the bar magnet. It turns to be close to an X of the metal bar. Figure 7.1 and Figure 7.2 show the force between the magnet and the bar in each case. Okay. State and explain what you can deduce about the metal bar. Use the information shown in Figure 7.1 and Figure 7.2. Okay, so bar magnet, I'm gonna answer bar magnet XY. Sorry, okay, wait. Bar magnet XY is a permanent magnet, of course. And then NX is south, yeah, south pole, while Y, while Y is north. Okay, north. Okay. Okay. Yeah. Next. Shows two bar magnets on a piece of card. Okay. And then describe an experiment to show the pattern of the magnetic field between the bar magnets. If these are two magnets, and for example, if this north pole, okay, and this bar magnet N is south pole, okay. So I'm gonna draw the, okay, Yeah, what is, yeah, the magnetic field. Uh, the magnetic field direction, like this. Okay. It will be attract each other better like this. Okay. Okay. The symbol meaning they will attract each other. Describe an experiment to show the pattern. Okay. So if I'm gonna say if n of uh, first paramagnet is north and another one, another n bar magnet is south. Uh, yeah, they would be they would be attract one another. That is the magnetic field. The magnetic field uh, will be drawn as attract each other as well. Sorry. Yeah, like that. So you may add the the pattern, the line, okay, from this to the pattern, and they have to attract each other. Okay, okay. Number 8. Figure 8.1 shows an electric circuit set up by a student. Okay, using standard symbols, draw a circuit diagram for the student circuit. Okay, so we're gonna draw the circuit. So first the okay battery. So battery symbol like this. Okay, and this pole. We need to check which one negative and or positive and negative. Okay, sorry. Okay, this one is minus or negative pole, and this one positive pole. Okay, and afterwards, this is the switch. The switch here, the switch position here. Okay, okay, and then after that, ammeter. Okay, the ammeter here, and then after that, after ammeter, oh, lamp. Okay, with the electricity object symbol like this. Also resistor, of course, and then okay, resistor, but I'm going to use resistor symbol like this. This is the symbol of resistor. Okay, okay, that's one. When the switch is closed, the there is a current in the circuit. Correct. State the name of the particles flowing in the metal wire, of course, electrons. Okay. Next, the current in the 15 ohms resistor in figure 8.1 is 0.4 amps when the switch is closed. Calculate the potential difference across the 15 ohm resistor. Okay, so see, we should calculate with this formula the potential difference, or V equal I times R. Okay, I is electricity current, while R is resistor. So I equal this one 0.4, so 0.4 amps times 15 ohms. Okay, and it's gonna be this zero, sorry, 6 volts. So the answer here, 6 volts. Okay. Number 9. Figure 9.1 shows a transformer used on a building site. Okay. The main plug for the transformer contains a fuse. Give a reason for why the plug includes a fuse, of course. Uh, yeah, it needs fuse. Yeah, because fuse will protect. Okay, it needs fuse because fuse protects the transformer from overheating. Okay. Next, explain how a fuse works. If uh, if a large if a large electricity current flows through in fuse, eh, it will be bricks. Okay. I mean the current, the electricity, the large electricity current will be bricks. Yeah, yeah, it will be brick the fuse, and then yeah, and then will sorry, and will mm, and will prevent the electricity object or transformer. Okay, okay. Yeah, it will prevent the electricity object or transformer from the overheating. Okay. Next, the main input or primary potential difference to the transformer is 230 volt. Okay, this is the primary. Okay, okay, or VP. The number of turns on the input primary coil is 314. The number of turns on the output of secondary coil is 150. Calculate the output of secondary PD from the transformer. Okay. The formula to find the solution equal is, yeah, Vs over Vp equal equals Ns over Np. So if you're gonna find Vs, or if Vs is the subject, we may arrange this formula becomes Ns over Np times Vp. Okay, so Vs equals Ns. How much Ns? Number of this one, this secondary 150. 150 over, and P how much? This one 314. Okay, 314 times 230. Okay, and equals um okay, I will calculate. Okay, 109.87, or we may round off becomes 110. Okay, that's the solution. Figure 9.2 shows an outline of the transformer. Okay, state a suitable material for the core of the transformer. Okay, the transformer uh, created by use of iron. Okay, and then what else? State a suitable material for the primary and secondary coils of the transformer. Okay, that is Cooper. Okay. Next, explain how figure 9.2 shows a step-down transformer. Okay, look. Okay. The primary coil uh, is 314 turns, while the secondary coil is 150 turns. So, a primary coil, amount of primary coil greater than secondary coil. Yeah. So, this condition we call as the step down transformer. If step up transformer, uh, primary coil should be less than secondary coil. So because a primary coil greater than secondary coils. Yeah. Okay. Alpha particles, beta particles, and gamma rays have different characteristics. Correct. Complete table 10.1 by indicating with a tick the correct type of radiation for each characteristic. The first row is done for you. Okay. Now, electromagnetic wave, yeah, gamma rays, input of gamma rays, less ionizing, less ionizing, this one, I think, in type of radiation input of gamma rays. Okay, and then less penetrating, which characteristic or alpha particles. Okay, a helium nucleus as well, alpha particles, and then negatively charged. That's characteristic of beta particles. Okay. The nucleus of an isotope of plutonium has 94 protons and 147 neutrons. The chemical symbol for plutonium is Pu. Write the nucleate notation that describes this nucleus. It means Pu, Pu, and then 34 here, and 94 here, I mean, 94 here, and 147 here. Okay. A sample contains 8 times 10 power 12 atoms of radioactive isotope of plutonium. The half-life of this isotope of plutonium is 14 years. Calculate the number of atoms of this isotope of plutonium remaining in the sample after 28 years. After 28 years, it means 2 times of 14 years. Okay, 2 times of 14 years. It means it becomes 2.5. Okay, if 2.5, it means the number of plutonium, it becomes 8 times 10 power 12 times half. Okay, there are two times half. Okay, 20 years, 28 years. It means 14 plus 14, 2 times 14. Okay, so it means 2 times half. Okay, uh, okay, and it's good. 8 times a half, 4 times a half equals 2. So 2 times 10 power 10 to power 12. So this is the answer. 2 times 10 to power 12. Okay, done. Okay, students, thank you for joining with me in this lesson. See you.